This is Scott Ritchie, and this is Mathematical Models of Pressure Control Ventilation. And I'm going to be talking about today my max minute ventilation and max tidal volume, and what variables are involved in obtaining these. So the main key players is my inspiratory time fraction, and this is affected by my duty cycle or my IE ratio or my inspiratory time. And then I also look, it's a function of my inspiratory time fraction and my inspiratory and expiratory resistance. So for a given level of applied pressure or pressure control setting, there's a max value for my tidal volume or minute ventilation. So if I multiply this inspiratory pressure of 20 to 50, I should get a max obtainable tidal volume of 1 liter and a max obtainable minute ventilation based on my respiratory rate multiplied by that max tidal volume I can get. Now, when my inspiratory and expiratory resistance are equal, my optimal duty cycle setting or IE ratio setting is a 1-to-1 IE ratio. So let's go ahead and look at, I have a duty cycle now set at a 1-to-2 IE ratio, and we're not attaining our max minute ventilation we can obtain. So on a respiratory rate of 20, I'm barely getting 20 here. So I'm just going to change this to 50% or 1-to-1. And as you can see, I'm obtaining my max minute ventilation obtainable. And then if I made this an inverse ratio, if I increased it to, let's say 60% or even 70, it's going to drop my minute ventilation actually. So I can't lengthen my inspiratory time anymore and gain anything else. So let's go change this back to my 1-to-1 ratio or my optimal duty cycle setting when my resistance are the same. Now what happens if my inspiratory resistance is more than my expiratory? So I'm just going to change this to 10 and let's see what happens. So with a duty cycle of 50% or 1-to-1 IE ratio, I'm not obtaining my max minute ventilation on a respiratory rate of 20. So in this case, actually, the optimal duty cycle setting or IE ratio setting is going to be greater than 50% or greater than a 1-to-1 IE ratio. So I'm going to just change my duty cycle to 60%, make it an inverse ratio. And as you notice, I'm obtaining more of a minute ventilation. And let's go ahead and change that to 65. Didn't really gain much more. Let's go to 70%. And so kind of around 60% was my max. If I go to 80, make it a more inverse, I'm not gaining anything else. I'm actually dropping my tidal volume. I'm going to change that back to 1-to-1, my optimal setting, if both are equal. However, what if my expiratory resistance is more than my inspiratory? And I'll change that now. As you notice, on a 1-to-1 IE ratio, I'm not attaining my max obtainable minute ventilation. If we look at a respiratory rate of 20, I should, based on this compliance and pressure, I should be getting 20 liters per minute. I'm not. So in this scenario, a duty cycle that's less than 50% or 1-to-1 is more ideal. So I'm going to change this to a 1-to-2 IE ratio. And you notice I'm getting closer to my max minute ventilation. Let's try 25% or 1-to-3. And it didn't do much better. But a IE ratio of less than 1-to-1 is going to get us close to our max minute ventilation obtainable.